Hi, good evening students. Now we are going to study something about elastic collision in one dimension. We have already studied the two types of collisions are elastic collision and inelastic collision. In both the type of collisions, one physical quantity is definitely conserved. What is it? That is linear momentum. But what is the difference between these two collisions? In elastic collision, kinetic energy also will be conserved. Whereas in the inelastic collision, only momentum will be conserved, but kinetic energy will not be conserved. Now we are going to discuss elastic collision in one dimension. So, what do you mean by one-dimensional collision? That means the two colliding particles or the two colliding bodies will have to travel along the same straight line before collision and after collision. Here there are two objects of masses m1 and m2 which are traveling in the same straight line. I am going to assume that this u1 is greater than u2. Imagine one car is going forward, another car is coming behind, but at a greater speed along the same straight line, means there is every chance for the second car to collide with the first car because its speed or velocity is greater than that of the car which is going forward. So I have considered that a car u1, that is a velocity of m1, namely u1 is greater than u2. This is the condition. So they are going to collide along the straight line. Now after collision, what is the velocity of the two bodies respectively? They are v1 and v2. So initial velocity before collision are u1 and u2. Final velocities after collision are v1 and v2. In this type of topic, what is to be derived? We are going to derive an expression for the velocities v1 and v2 after collision in terms of the velocities u1 and u2 before collision, and the applications and the special cases that is very important to solve the numerical problems in the NEET and JEE. So now we are going to derive the equations for v1 and v2 in terms of u1 and u2. Okay students, I will consider first the law of conservation of linear momentum. So according to the law of conservation of linear momentum, the total momentum of the system before collision must be equal to the total momentum of the system after collision. Our system consists of how many bodies? Two bodies. So their masses are m1 and m2. So the total momentum before collision, I will say P initial is equal to the total momentum after collision, that is P final. Okay. Now you see that m1 is the mass of the first body, u1 is the initial velocity of the first body. So the initial momentum of the first body is m1 into u1, and the initial momentum before collision for the second body is how much? m2 into u2. So what is the total momentum before collision must be equal to m1 into u1 plus m2 into u2. This must be equal to what? The total momentum of the system after collision. So what is the final momentum of the first body? m1 into v1, and that of the second body is what? m2 into v2. So this must be equal to what? m1 into v1 plus m2 into v2. Now I am going to rearrange the terms in the above equation. So all the m1 terms on the left side and m2 terms on the right side, I am going to shift the terms. So this also can be written as what? m1 into u1 minus of m1 into v1, and this is equal to m2 into v2 minus of m2 into u2. Okay, Now what are the common factors on both sides? The left side common factor is m1. So I will take m1 into u1 minus v1, and this is equal to right side common factor is m2, that is into v2 minus u2, and this is the main equation required, that is equation 1. So this equation is the fundamental equation. So this equation will be referred again in the next step also. So this is the main equation. First equation, if you have derived correctly, then everything will be correct. Have you all understood this equation 1? So what is equation 1? m1 into u1 minus v1 is equal to m2 into v2 minus u2. This equation is derived based on which principle? The conservation of linear momentum. Next, I am going to apply the conservation of kinetic energy. Understand? So the next step is based on conservation of kinetic energy. So what is the meaning of this? The total kinetic energy of the system before collision is equal to the total kinetic energy of the system after collision. So the kinetic energy of the first body is half m1 u1 square, and that of the second body is half m2 u2 square. So I will write half m1 u1 square plus half m2 u2 square. So I have added this left hand side is now equal to what? The total kinetic energy of the system before collision. Is it not? Like that. Now you tell me what must be the right hand side now? It must be half m1 v1 square plus half m2 v2 square. So this is half m1 v1 square plus half m2 v2 square. So the factor 1 by 2 is common for all the terms. So I will cancel this half. So 1 by 2 is cancelled. Once again, this m1 terms can be grouped on one side, and m2 terms can be grouped on the other side of the equation. So this becomes what? m1 u1 square minus m1 v1 square is equal to m2 v2 square, m2 v2 square minus m2 u2 square, m2 u2 square. Once again, what is the common factor on the left hand side is m1. So shall I take m1 on the left hand side common factor? So I will write this m1 into u1 square minus v1 square. Are you able to see the board? Is it visible? Good. Like that, the right hand side now, which is a common factor, m2 into v2 square minus u2 square, v2 square minus u2 square, and this is main equation 2. I hope you must have understood the first equation, the second equation. The equation number 1 is based on the law of conservation of linear momentum, and the equation 2 is based on the law of conservation of kinetic energy. The total kinetic energy is conserved in elastic collision. Now I am going to divide the equation 2 by equation 1. It's very simple. So I will dividing equation 2 by equation 1. Totally left hand side is divided, and also the right hand side. Okay, so you see that equation 2, what is the left hand side? It is m1 into u1 square minus v1 square, and what is on the right hand side? m2 into v2 square minus u2 square. This is equation 2 I have rewritten, divided by equation 1. So I will divide on the left hand side by m1 into u1 minus v1, and the right hand side I will divide by m2 into v2 minus u2. So which term gets cancelled immediately? m1 get cancelled on the left hand side, m2 gets cancelled on the right hand side, and You see in this bracket in the numerator, it is like a square minus b square term. We can express that in the form of what? A plus b into a minus b. So this becomes u1 plus v1 into u1 minus v1 whole divided by u1 minus v1, u1 minus v1. And this is now equal to right hand side. It is also a square minus b square term, is it not? So a plus b into a minus b form I am going to write. So this will be what? v2 plus u2 into v2 minus u2 and whole divided by v2 minus u2. So this is v2 minus u2. Again now you can see that this v2 minus u2 can be cancelled, and here u1 minus v1 can be cancelled. So I am cancelling these two terms and these two terms. So what is remaining now? u1 plus v1 is equal to v2 plus u2. This is the equation which is arrived by dividing the second equation by the first equation. Now this I am going to rearrange in different possible ways, because in competitive exam many types of questions are being asked from this relation also. You can see here. So this is u1. This u2 is brought to the left hand side as minus u2, and this is equal to v2, and v1 is brought to the right side as v1. Okay. So this is u1 minus u2 is equal to v2 minus v1. This left hand side u1 minus u2 is called as velocity of approach. This is called as velocity of approach, and the right side is called as velocity of separation. This is called as velocity of separation. One more term also we can use. This u1 minus u2 is a difference in the initial velocity before collision, is it not? So u1 minus u2 is also called as the relative velocity of the two bodies before collision. Similarly, v2 minus v1 can also be called as what? Relative velocity of the two bodies after collision. But technically, the left hand side is called velocity of approach, the right hand side is called velocity of separation. Understand? Now once again I am going to rewrite this equation on the top. The same equation. You see here this equation, for example, I will number this as 3 for your reference. The third equation I am going to rewrite once again. Understand? So this left hand side is u1 plus v1, u1 plus v1. This u2 is brought to the left side. So it becomes what? Minus u2. So what is this equal to? v2. Understand? This is equal to v2. I will shift this v2 to the left hand side. So v2 is now equal to what? You can write this v1 plus u1 minus u2. So this equation is required for us, very important equation. So this is numbered as 4. Equation 4 is very, very important. I am expressing the final velocity v2, okay, in terms of the other factors like this. So v2 is equal to v1 plus u1 minus u2. In the same way, I will express v1 in terms of the other two terms. So I am going to rewrite the same equation. See here, what is v1? So v1 is now equal to what? v2, okay, minus u1, okay, plus u2, so, and this is equation number 5. So these are the two equations which are required for us. Now up to this, if you have understood, means after this it is very, very easy, because either equation 4 or equation 5 has to be substituted in the main equation 1. The first equation you see here v1 term is there, here v2 term is there. Okay, you can substitute for v2 the equation 4. If you substitute the equation 4 for v2, where? In the first equation, finally you will get an expression for v1. Suppose if you substitute the equation 5 for v1, in this equation, if you substitute for V1, then you will arrive at an expression for V2. So, V2 if you substitute means expression for V1 you will get. Suppose if you substitute for V1 in the first equation, you will get an expression for V2. Anyhow, both are very important for us. Okay, shall we substitute? So, up to this, you must write continuously. Now, I am going to rub some of the steps and I am going to substitute equation 4 or 5 in the first equation. Are you ready? Okay. Yes, now we are going to substitute for V2 in the first equation. Okay, for this V2. So, in the first equation, M1 into U1 minus V1 is equal to M2 into, instead of V2, I will write V1 plus U1 minus U2. So, instead of V2, I am writing V1 plus U1 minus U2. Now, already one more minus U2 is there, you should not forget. See here, in place of V2, how many terms? 1, 2, 3 are there. In place of V2 alone. So, those 3 terms I have written in place of V2. What is the other term also there? One more minus U2 is there. So, that U2 will come like this. So, this M1 into U1 minus V1 is equal to M2 into V1 plus U1 minus 2U2. This U2, minus U2 and minus U2 will make this as what? Minus 2U2, is it not? Okay. Now I will open up the bracket. I will open the bracket. First term will be product of M1 into U1. Yes. Minus second term is M1 into V1. And the right hand side first term is M2 into V1. M2 into V1. Plus the second term is M2 into U1. Minus 2 into the last term is M2 into U2. Understand? Now, after this, you must bring the grouping of all the U terms, U1, U2 terms on the left side or the right side, any one side, and V terms on the other side. Now, in this, I will retain this M1, U1, okay, M1, U1. Then here this M2 U1 will be taken to the left side as minus M2 U1. Then again this minus 2 M2 U2 will come to the left as plus M2 U2. Plus M2 U2. This is equal to, right side all the V terms I am going to retain. Right side V terms. Left side all the U terms. Okay. So the right side V terms, first term is what? M2 into V1. This minus M1 V1 will come to the other side as plus, okay, M1 V1. Understand? Now, which are the common terms? Once again, see M1 U1 minus M2 U1. See this U1 and U1. Okay, here V1 and V1 common factors are there. So I will take U1 as the common factor. U1. What is the remaining term? M1 minus M2. M1 minus M2. What is the remaining second term? Plus 2M2 into U2. Now here V1 is the common factor. So V1 into M2 plus M1 also can be written as what? M1 plus M2. In this order you practice always in the ascending order of the masses. Okay. So M2 plus M1 is also what? M1 plus M2. Yes. Now we have to derive expression for the final velocity in terms of initial velocity, is it not? You see beautifully we have derived the equation. We need an expression for V1 in terms of U1 and U2. So I will write R V1, okay, R V1 is equal to, V1 alone is equal to, first term is what? U1 into M1 minus M2 whole divided by this M1 plus M2, M1 plus M2, and second term is plus 2 into, okay, plus 2 into M2 U2 divided by, okay, so this is M1 plus M2. So this also can be written as plus this. I am going to rearrange this equation. Okay, what is this? 2m2 u2 also can be written as what? U2 into bracket 2m2. So that there is one small step you can remember forever by modifying this term. What is that? I will tell you. So this 2m2 u2 also is split up like this, u2 into bracket 2m2. Both are one and the same. So this is the final equation required. Understand? This is the final equation required. So after this it is equation 6. You tell me, children, we substituted for v2 only now. In which equation? In equation 1 we substituted v2. But what is the final expression we have arrived is for v1. Similarly, if you substitute the fifth equation for v1, v1 is substituted here in the first equation, you will end up with what? v2. You will end up with what? v2. So you have to try now. You have to try. But what will be the final equation? We can say that similarly, understand? Similarly, if you substitute for v1 in equation, then you will arrive at the expression for v2. So here it is v1. If you write this expression for v1, what is the first term is u1. Understand? So if you write here v2, the first term must be what? u2. Here u1 means here u2. Here m1 minus m2 means here m2 minus m1. So this is m2 minus m1. But the denominator is always the sum of the masses only. No, that is the same, m1 plus m2. Then again, here u2 is written means here u1 into here 2m2 means here 2m1. And here also the denominator is what? m1 plus m2. And this is another step, equation number 7. So this is our task in this elastic collision in one dimension. How the question will be asked for 5 marks? Discuss elastic collision in one dimension and derive the expressions for the final velocities of the colliding bodies in terms of their initial velocities. That means you have to derive expressions for v1 and v2 in terms of u1 and u2. Have you all understood? Okay, now based on this, there are so many special cases. What are the special cases? If both the bodies are having the equal mass, m1 is equal to m2. Wherever m2 minus m1 or m1 minus m2 is coming, it will become 0. Suppose if the second body is at rest, means u2 is equal to 0. Suppose if the first body is having a extremely large mass than the second body, like that, special cases are there. So depending upon the case, you can apply the case in the two equations. So any case in competitive exam, they ask the two basic equations required are v1 and v2. Once again, I am telling you the shortcut. If you want to derive an expression for v1, okay, for v1, then on the right hand side you have to write u1. u1 means what? m1 minus m2 plus, okay, u2 into 2m2. Like that, v2 means numerator you have to remember, you start with u2 and it is m2 minus m1 plus u1 into 2m1. You have to remember the numerators easily. I hope you have understood well. Fine.